Hi friends, jumping into Unit 4, Day 1, inverse functions. An inverse function, f inverse of x, is found by taking the operations on the range or the y values that will return the function to the domain or x values. And then with ordered pairs, essentially all that you need to do is, if you have a function that's an ordered pair, if you just swap the domain and the range, then you get the new function called f inverse of x, and we say f inverse of x is the inverse of f of x. So finding the inverse, we can use an algebraic method. So instead of using f of x, we just substitute or swap y for f of x, then we interchange both the x and the y, and then solve our equation for y, and then we get to our final result of substituting f inverse of x for y. Note that this inverse notation, f inverse, does not mean 1 over or 1 divided by f of x. This means something different, so be careful. So let's do an example of that. So here, example 2 says find the inverse. So when we have just an ordered pair, to find the inverse of this, we just swap the values. So this is f of x. So f inverse of x is equal to, so we just swap each of the values. So it's this set, so it's set notation, the set of, and so then I just change 3, comma, negative 2, 7, comma, negative 1, 4, comma, 0, 2, comma, 3, negative 1, comma, 6, and then 0, comma, 7. And then we close the set to show that it's a closed set bracket. Number 2 here, we do a little bit more because this is now changing it to algebraically. So step 1, we just change your f of x to y. So this is y equals the cubed root of x minus 2. Then you swap your x and your y values. So this is now x equals the cubed root of y minus 2. And then now we solve this new one for we solve this one here for the y value. So essentially we need to get y by itself. So I'm going to now, what I usually do is I end up, to show my steps, I rewrite this one here after I swap. I rewrite it again. And then when I cube both sides, it's easy to see exactly what happened when the swap occurred. So this gives me x cubed equals y minus 2. Add 2 on both sides. So I have y equals x cubed plus 2. And then I interchange y now with f inverse of x. And this is the inverse of my original function. So the inverse of f of x is f inverse of x, x cubed plus 2. With this one down here, number 3, it's a little bit different because we have to swap both of the values. So let's see what happens here. So first unchange, so y equals 3x over x minus 1. So now I'm going to swap both of these values. So y becomes x, and x becomes y. So first thing I want to do, again, I'm going to show it over here. X equals 3y. I want to multiply both sides by that y minus 1. And then cancels with that. I'm actually going to leave it as y minus 1 times x. I'm not going to distribute through just yet. Deciding what color pen to use. So x, so I just swapped them here, equals 3y. All right, so now I want to get, let's see, so I need to divide by y here. That'll move the y to that side. And then divide by x to move the x over to their side. Ooh, no, I want that to be in the numerator. Wait, hold on. All right, so I said divide by y. I don't want to divide by y. Taking it back, I actually need to distribute x times y and x times negative 1, so I get minus x. equals 3y. Now I can subtract 3y from both sides. I knew I was going down the wrong path because I started dividing by y, and we don't want to divide by the variable that we're solving for. So I have xy minus x minus 3y. There we go. So here now I want to equal 0. So now I want to add x on both sides. Add x, add x. So here now I have xy minus 3y equals x. So now I can factor out a y from both of these. And I get x minus 3 equals x. Now I can divide by x minus 3. And I get y equals x over x minus 3. Then I substitute f inverse of x in for that. There we go. Now in some cases we have a situation where we need to restrict the domain. So here I have f of x equals x plus 2 quantity squared. Restrict the domain to create a one-to-one function and then find the f inverse of x. If you think about this particular graph, this is a quadratic, and similar to the quadratic that we talked about from earlier, is that essentially it's not one-to-one at the kind of the vertex, wherever that vertex is. That's where it starts repeating. These x values are going to repeat to have the same y values. So what I need to do is I need to restrict this domain so that I can have a one-to-one function. So my domain restriction in this case has to be in a situation that when I have my unique x values, that it gives me unique y values. So my domain in this case, I want x to be greater than or equal to negative 2. Negative 2. And that'll give me unique y values. If I plug in negative 2, I get 0. If I plug in negative 1, I get 1, and so on. So just be mindful of what you need to do to essentially make this. What I knew from this graph is that it did something like this. And so right here is where I wanted to restrict the domain, there and to the right. I could have also had there and to the left. So that's my domain restriction. That makes it one-to-one. Now to find f inverse of x, just like what we did previously. So I'm going to substitute y in for f of x. X plus 2 quantity squared. Interchange x and y. So I have x equals y plus 2 squared. And then now I solve for y. So let's see, that's going to give me x equals y plus 2 quantity squared. So to get rid of that squared, I need a square root. So whenever we square root, plus minus, but here, this is where we're restricting the domain. So here, I am just going to have positive values. So because I restricted the domain, because x had to be greater than or equal to negative 2, what we're going to have here is a restriction on the inverse as well. So this restriction will also have to be able to have it also be one-to-one. And this is why we have to restrict the domain here in this case, because we have that plus and that minus. We get that duplicate. Same here on the graph. If you think, both the positive values and the negative values from this vertex. So that means we have square root of x is equal to y plus 2. Subtract 2 from both sides. So I have y equals square root of x minus 2. And then that is my f inverse of x. Notice that that minus 2 is outside the parentheses. And so if this is a one-to-one function, then I can take the composition. So we're going to verify inverse functions. We'll save that for the next video. Have a wonderful day.